Section 1, Pallet Side. This video will use a 3x2x2 palletizing application as an example to explain the palletizing plugin. First, we number the objects on the first layer. Then we create a new task and insert the palletizing package. Select Palletizing and input the height of the object. Click on Layout Type, then click Matrix. A matrix block will be inserted automatically. Click on Matrix, Edit Number of Objects. There will be 3 objects on each row and 2 objects on each column. For matrix layouts, the user needs to teach the positions of the object at the 4 vertex points. The vertices need to be taught in the correct order. Vertex 1 will be the first object. Vertex 2 will be the last object on the first row. Vertex 3 will be the last object on the last row. Vertex 4 will be on the first object on the last row. Simply put, the direction of the palletizing order does not matter, meaning the order of the vertices can be clockwise or counterclockwise. It cannot go via a diagonal path. If the second layer needs a different layout, just insert another layout and do the parameter configuration and vertex teaching for it. After the layout is taught, click on Layer and select the layout for the first layer. Then select Layout for the second layer. Click on At Each Workpiece and select the layout and reference position. Then click Generate Move. The generated waypoints are Approach Point, Tool Action Point, and Exit Point. Tool Action Point is taught by the system, so the user can just move to this point, then raise up a little as approach point and exit point. Select the output signal for opening the gripper under Tool Action. Be sure to give the gripper some time to fully open. Section 2, Object Source Side. Add our object picking up pattern to the task before the palletizing block. Then teach the picking up point and the approaching point. Section 3, Basic Task Flow. In general palletizing applications, when a pallet is full, it will be moved out from the palletizing station. Then, a new empty pallet arrives, and a new palletizing cycle begins. To make the task match with this basic flow, there are several items that need to be added to the task. First, program the robot to handle the situation when the pallet is fully filled. Click Pallet, then check Add Action after palletizing. Add a move instruction to make the robot go back to above the pickup location, then halt the program. Make sure the program is in cycle mode. Add a wait instruction. Make the robot wait for the signal that confirms the object has arrived at the pickup position. The robot will move only when there is actually an object to pick up. Configure an external signal for starting the task. It can be a push button or sensor for starting a new palletizing cycle. Remember to save the configuration and the task. Run the task. Robot moves to above the object. After receiving the signal that tells the object is in place, the robot moves to pickup position, then sends a signal to tell the gripper to close. waits for the gripper to close, and then pick up the object. Robot carries the object to the palletizing approach point, then tool action point. It tells the gripper to open, it waits for the gripper to open, and then goes to the exit point. The task loops until the palletizing is done. Then the robot goes back to above the object pickup position and halts the task. When the signal for starting tasks is received, the next cycle begins. Section 4. Selectable palletizing point. In real palletizing applications, sometimes there will be a fault, causing the task to pause or stop. After the fault is cleared, depending on the situation, the user might need the palletizing task to start from a specified palletizing point. Therefore, an interface to specify the palletizing point needs to be added. When the robot is running, the local variables generated by the palletizing plugin can be monitored. These variables are showing the current number of palletizing points, the number of current palletizing points for the current layer, the current layer number, whether isolating dunnage is in use or not, the total amount of palletizing points, or the position of the reference point. Making an interface that can modify the current number of palletizing points will accomplish the goal. This interface can be a combination of a digital input signal, an analog input signal, a signal by a Modbus register, or just simply a global variable since it can be modified easily on the teach pendant. With settings like this, when the task is running again, it will start with the 12th palletizing point, since the global variable current is 12. To ensure the task runs properly with the following loops, at the end of the program, the value of the global variable needs to be updated too, since the current palletizing point will be updated automatically when the program is running. The value of this local variable can be directly assigned to the global variable. After the entire pallet is fully filled, before halting the program, reset the global variable, so the next cycle starts with the first palletizing point. Section 5. Countermeasure for Singularity points. For applications with large amount of workpieces, some of the waypoints generated by the plugin might be near the singularity points of the robot. The general solution is to make the robot handle these workpieces with unique waypoints instead of generated waypoints. Assume this task will cause the robot to enter a singularity point when handling the 9th object. Using the variable that tracks the current number of palletizing points for selecting the program routine, if the current number is 9, then go to waypoint 1. Otherwise, go to the generated tool action points. Section 6. Isolating dunnage. In some manufacturing plants, the palletizing station normally has 2 pallets in a group, one for palletizing, the other for holding the dunnage. When palletizing has finished a layer, a dunnage needs to be placed to isolate the workpieces on the next layer from the previous layer. When the pallet is full, it will be moved to the next station. Then, a new empty pallet will feed in, as well as the dunnages. If the supplied dunnages for each cycle will always be a fixed amount, then the isolator block comes with the palletizing package and can be used to generate the dunnage handling program structure. Under Layout Types, check the isolator. Set the isolator height. Click Layer, check the isolator. For some situations, the last layer will not need a dunnage to cover the top. Then we teach the reference point for placing the dunnage, which is the placing position for the first layer. Click on Isolator Action, Generate Isolator Action. In the generated actions, the Dunnage placing position, isolator action, is automatically taught by the system, which should be where the robot is still currently at. Raise the robot up a little to teach the isolator approaching position and exit position. The isolator pickup actions need to be made manually. If there are equipment to ensure dunnage will always be supplied at the exact same height, then just design the motion with the object picking up pattern. Set the gripper open, close actions, adjust waiting time, and then the program for dunnage handling is done. Section 7. Action before palletizing. Action before palletizing is a section of program executed before the palletizing cycle. It runs only once for each pallet. If the dunnage at the very bottom of the pallet needs to be handled by the robot as well, then the program can be constructed here. Existing waypoints for isolator actions can be used as reference to make the action for placing the dunnage onto the pallet. For some applications, they require a vision system to take a photo of the dunnage to locate their position. These programs can be placed here as well. Section 8. Dunnage obtaining height automatic update. In some heavy industrial factories, there won't be any equipment to raise the dunnage up to a fixed height. So when a dunnage is taken, the next dunnage obtaining point will be lower. Therefore, the robot will need to lower the dunnage obtaining point according to the current layer number of the palletizing process. This video will use the obtaining point of the dunnage, which would be placed under the first layer as a reference. Clicking Edit Pose can let you view the tool position of the fixed waypoint. Record these numbers. In the Configuration tab, create a variable to store the reference point, which is the point we just recorded. Type the variable value in the format of a 6-element vector. Then create another variable for storing the dunnage obtaining point. Set all 6 elements to 0 for now. Change the waypoint for dunnage picking up from fixed position to variable position. Use the obtaining point variable just created. Then we make the program that updates the dunnage obtaining point according to the layer number. First, assign the value of the reference point variable to the obtaining point variable. Remember to add .copy parentheses at the end. The reason is because it is the same as the Python list variable mechanism. Script instruction allows users to write complex expressions. Simply put, this expression means changing the height of the obtaining point to the height of the reference point minus the product of the height of a dunnage and the current layer number.